Hey, what's going on, folks? It's Mike here, and welcome back to my software design series. In today's episode, we're going to talk about another design pattern, the prototype pattern. But I thought it would be fun if we went ahead and just dove into an example here to sort of motivate what this design pattern is for the prototype pattern. Whoa, look out here. Something's going on here. Okay, this isn't real life. This is from the game's Helldivers 2, which is very, very popular right now, and it's just a lot of fun here. So it's sort of this first-person shooter where you're cooperatively fighting these aliens here. Take a few more looks at some screenshots here in case you haven't played the game, in which I recommend you do. It's very, very fun. But anyways here, how is this working here? Well, we got a bunch of these soldiers here who look very similar. And we got these army of, well, aliens or whatever attacking us here. Okay, and there's many, many, many of these here. Now, something that I'm actually wondering about, though, in a game like this that's online, multiplayer, cooperative, where you've got lots of these sort of custom objects here with these characters and maybe variations of these creatures, is how do we instantiate all of these objects here? Right, we've got these many waves of enemies here, and they look like there's a lot of data there. We might have to duplicate these or instantiate them. So let's talk about this just a little bit here. And well, I mean, could be as simple as just allocating a bunch of memory for the aliens. Or maybe we could use some of the other patterns we've learned about in this series, because you've subscribed and watched these videos, and I've talked about things like a factory pattern, where we could create a vector of these aliens, pre-allocate or reserve 100 aliens, positions for them, and then use some factory with some parameters, as many different parameters as we could think of, to populate our aliens. I mean, this is certainly a choice, and full disclaimer, I didn't work on this game, so I have no idea if this is how they did this. But, you know, this is kind of, one, maybe boring if all of our aliens are the same, or we just have a limited amount of the type of, you know, these enemies that we can generate based off of our imagination with however many factories we can come up with. And we can template these things and come up with different parameters and config files, of course, but that is to say, the larger problem here, beyond the creativity, is that this might just take a lot of time, because, well, what's happening when I'm doing these factory functions is hopefully I'm doing them in an intelligent way. But in the worst case, I'm doing them in some unintelligent way where I'm downloading a bunch of information from the web. Maybe I'm downloading these configuration files. Maybe the process of creating an alien means going to some database somewhere and querying for something very expensive. That's a lot of latency. So effectively what we want to do is create one of these aliens once, have all the resources locally on our machine, or that is to say allocated in memory exactly one time, and then we can make a copy or a clone, that is to say a prototype of that particular object, and then just reuse it and change the details and the underlying data. So that is the essence of the prototype pattern. So hopefully that's a motivating enough example to give you the idea of what the prototype design pattern is, or at least a fun way to think about it. But it is a way to create new objects. So again, it falls in that category of creational design patterns. So here's the full definition here from the wiki. I'll give you the highlights here. Basically, it's a way to create other objects from a prototypical instance. So some previously created object that you have created, and you'll call a usually named clone member function to produce a new object. And that's going to avoid some cost potentially of creating the object. So for instance, if you have, again, a object that has to be created by connecting to some database or downloading something from your disk or looking some config file up, that could be more expensive than just grabbing what's already in memory and making a copy of it. So that's the idea of this particular pattern and where it could be useful. So again, you can think of it like mitosis, cells being cloned. That's often why you have the member function or a function called clone for making copies. And you're going to see our implementations as simple as the copy constructor, but we're going to explicitly label out this clone member function so we know exactly what it's doing and its purpose. It's basically building in a sort of factory or way to create new objects from the current instance of some object. So that's the idea. Here's sort of the formalized pattern here that you'll find on various documentation here. But for our interface, all of our, well, anything that is able to be cloned will have a clone member function. And each of the concrete prototypes will implement their own version of this clone function. Sorry, this is in small font, but that's what's going on there. And again, as mentioned, we'll basically just use the copy constructor here. So Again, when we use this, if you have a really, really long setup process, potentially a setup process of objects going to contact other services or otherwise just take a long time, maybe it's very IO bound task for setting up some object or going to a network, then this is a good pattern to use. And of course, the idea is if I'm able to just clone my object one from the other and maybe toggle a few parameters of it, that could be another reason that you want to do this. You don't want to have a bunch of concrete instantiations or subclasses that already have an object. You just want to create some base object. Think of it again in the example of our 3D aliens that we had, and then be able to tweak some of the parameters, maybe just a few of the little parameters to make those objects different enough, but not have to have generated code and concrete classes for that particular object or resort to inheritance. Okay, so that's the idea here. And again, we've looked at other creational design patterns. So singleton, we've looked at factories. We'll look at builders eventually, or maybe they'll already be in the playlist. So make sure to check that out and say subscribed otherwise. And that's the idea here. Okay, and then I'll point you to courses.mshot.io later once we actually implement this. So let's go ahead and just build a class here. And let's kind of do something like we were seeing here. Let's build an alien class. I'm going to give these aliens maybe an ID. Let's give them a name because, you know, all aliens should have some name here, and maybe some data here. Now, the data here, we'll have to use our imagination just a little bit, but let's just go ahead and create maybe a vector of integers here. And this is going to be the stuff that we are effectively cloning. Now, we might want to change some of these things ahead of time, like the ID, to make sure they're unique in some way. But let's go ahead and just get this working first so that we can kind of proceed. Okay, so let's go ahead and just create our alien, and we're going to call this the default one. Again, it's not going to be super, super interesting, I suppose, here. And we should probably put a little underscore here since default's a keyword in C++. And we should probably write in some sort of constructor for this. So let's go ahead and create the constructor here. I'll label it as such here. And I guess let's go ahead and give this a ID. And again, it could be an integer ID. So I suppose we could allow negative values here. Let's give it a name. And we will assign that as such here. And let's be a little bit more consistent with my naming here. M name, there we go. And I think that'll do the trick here. And we could use a initialize a list here to set this up. So let's go ahead and just do that here. MID will be the ID, and mname will be whatever the name is that's passed in. So that's kind of a nice, clean way to do something here. And you know, for now, our data will just be empty. Okay, I'm just going to use that as an example here. So let's see. Let's go ahead and create this as default, you know, alien, and 0 will be the ID here. Okay, so let's go ahead and do that here, and we should probably print out this object here. Print for, you know, debugging purposes. This could be useful in your actual debugging code or from a debugger here, but for us. Right, we're going to want to write out the ID here. And I'm going to use standard out, or rather C out for doing my printing. But of course, if you've got a version of C++23 with print, this is another nice use case to use it with format specifiers. In fact, maybe let's just do it. Since I bothered to mention it, let's just include print here. Let's see if I can do it without any typos. But let's just do print line here. And then we've got to let's set this up here. Let's see, we'll put our 0th and 1 parameter here, and first parameter rather, and that's going to be the ID and the name, and that's actually quite nice here. And let's do default, default, print. Let's see if we've got this much working before we proceed forward here. Oh, let's see, no such thing here. That's because you know, I need a later version of, let's see what version of G++ I'm using here. Well, at the least I need to make sure I'm on C++23. Okay, I believe I have 14. There we go. All right, almost got it. Just a few typos here with the ID. Let's make sure that's MID here. And since we're using a class here, the default is private, so that's probably why we're getting some errors. Okay, so that's working here. And every time we compile successfully, let's go ahead and run. And we should see our default alien here, okay? So there we go. We've got a way to create some object here. And just to make this object interesting, let's say this data is meaningful. Let's say that this is like the, I don't know, values for the coordinates that the alien is going to spawn from. It's got a bunch of other integers that mean something, and they're downloaded from the web, right? So, we want to set up our alien coordinates. So I'm going to call this setup alien data here. And let's just call this like data, I don't know, download or something, right? Imagine this is some task where I need to download from the web some data here. And for this, I'm just going to do some task that simulates, taking time. So maybe just a loop here. And we're going to do this super, inefficiently here. We're just going to push back all the integers here. I'm not going to reserve the data ahead of time or whatever, right? It's going to be some slow operation because, again, we're simulating, querying some slow operation here. So simulating some slow operation for setting up our object. Okay, that's the idea here. And let's go ahead and do that here. So for our default alien, let's print. And just to make sure this is working in our print function, let's go ahead and write out using a for loop here some of the data here. So let's say, let's just call this for each of the elements here in mdata. Yeah, we could write them all out. That's fine. And do I want to use print line again? Let's just use print. And I'll use the format specifier string here. Whoops. We got a lot of curly braces going on here. 0. There we go. And our element. Okay, let's see if this does what we want. It should. Oh, maybe not. Oh, we got to set up our data download here. Data download. Okay, and then we should see a whole bunch of data. Okay, there we go here. Okay, it's not too bad, but we can confirm that it is, in fact, set up here. Okay, so now what we want to do here, let's get to the actual prototype pattern here. Now that we've got some objects set up here, we want to create using, well, basically the copy constructor, a clone of this object. So this very, interesting default object where I only want to pay the cost of downloading this data once here. So pay cost one time of expensive operation here. Okay, so that's the idea. Let's move this over here. So let's start by writing a copy constructor, which I'm going to go ahead and do up here, just to save us a little bit of space here. And the copy constructor is what I'm going to use as my sort of thing that I need for my prototype here. Okay, so again, this is going to be the alien, and then I will use const here for the right-hand side. Let's pass it by reference. And MID, of my copy is going to equal, well, what should it equal? Maybe let's just give it some value so that we know it's a copy like -1 here. Maybe that's something that we need to more carefully like statically assign or increment this value, right? I could make this a static variable and just have it increment every time. That is one option. That way you'd always have a unique value. But anyways, that's one decision that you can make here. And then otherwise, let's go ahead and take the right-hand sides, mname. Or we could just say it is a clone, right? To indicate that is a copy or something, right? So again, it depends what rules we want to play by. But let's say it is meaningful to otherwise just take the right-hand side's name. Let's go ahead and do that. And our data, right? This is the expensive thing, right? We're just going to take the right-hand side's data and make a copy of it, okay? Now, of course, you might be saying, Mike, if I've got the copy constructor, why do I have to write some other function, right? This is good enough, right, for me to make copies of other objects. And that's a pretty fair assessment, but a few things here. One, let's go ahead and write out our clone function. It's very explicit. We can parameterize it if we need. And I have some control over, what I want to do with my clones, meaning if I want to basically make like a return a pointer to something, or, is it a new object? Again, I have some control over this. So I'm going to write this, and some of you might have caught this. I included memory here, such that I'm going to return a unique pointer here to this alien type here. And that's going to be my sort of standard interface here. Okay, and I call clone, so this is easy to grab for. And again, I could add parameters here if I wanted something, like maybe I do need to decide like what the ID is. Okay, so I want the copy, but I still want some maybe interesting customization here that I could have in one sort of interesting place. But the base pattern is just to, again, have in my interface some clone object here. Okay, so I can do this in one step. I'm going to break this down into 2 steps where I have my unique pointer. My alien, I'm just going to call it the clone, and use std make unique. What's going to make a unique thing of? It's going to make a unique thing of the alien. And what's it copying? Well, it is copying this here. Okay. Let's make sure I have all my parentheses, and let's just return the clone here. Okay. You could do this in one step. You could just return make unique. That's fine. But I have it in 2 steps because, maybe other stuff here if you wanted to use some other system. And the thing I have in mind for this particular example is like assigning IDs in some more intelligent way. Maybe you'd want to queue these up or something, but or have to name these with some parameter. So again, there could be other stuff you want to actually do to your clones here. Let's just compile this and make sure it's still working. Still working. That's great news. Always good news here. But hopefully folks get the idea here. I'm going to go ahead and the less interesting stuff here, let's go ahead and just hide this. So I'll just fold that in Vim so that we can have everything in our context here. Okay, and then let's go ahead and make a clone here. So how do I do this? Well, I want a new, and again, these are going to be pointers that I'm returning to alien because now they're going to be some other object that I have here. And let's call this the super alien. Okay, so he's going to serve sort of as a, I don't know, super alien, where we want it to have all the stuff from the default guy here. But, we're going to eventually change some parameters here. The default, I'm going to call clone on it. Okay, let's see if we're happy with that much so far. We are. Okay, now here's the test here. Let's see if I got everything set up here. So our super alien, and sorry I made that capital. Let's make that lowercase because it's locally scoped. Let's do a print on it. And I do actually want to fix our little print function here. This is bothering me. Let's do a print line here. Let's see. Can I pass that with no parameters? Let's see. No, I can't. Okay. Darn. All right. There we go. Just because I wanted a space here. Oops, it doesn't like print. I always forget what language I'm in sometimes. This is a pointer. So there we go. All right. And there we go here. Okay. So this looks like everything is working here. Okay. I've got my original alien here, which I've printed out. I've done the data download step just one time here. And then I made my clone here, which is a perfect clone. It's just a copy. And again, that copy here, just to be clear, let's hide the less interesting stuff here. Let's fold those. This again is doing, it's using the copy operations for string and vector. So it is doing the proper deep copy. Again, you need to do the right thing for your copy constructor here. But I am getting my super alien here with the data of my default here, alien, without having to pay the cost of, this super expensive, as I've hypothesized, let's say data download function here. Okay, so that's part of making copies, but now we have a common interface to do it through clone. So that's the idea with this pattern here. And the idea is now that I have this, super alien here, let's go ahead and change one of those parameters here. So super alien, let's just, I've just got to access the data here. Let's just make the value. So this first data, maybe that's a really important attribute here. Let's just make it a 9, okay? Just so we can see that there's difference in the copy. Oops. And again, I'm going to keep making this mistake. I've gotten used to other languages where I could just do dot. Right, I do see the 9 there at the front here. Okay, now I can make instances of this object, and so on. And again, I think you could do some interesting stuff with clone, again, depending on the language that you're using here, to add more power, maybe with some metaprogramming stuff to instantiate a bunch of these things. But again, it's really giving you a lot of control over that copy constructor. Or, again, the point is, right, in my copy constructor, I can't anticipate what data that I'm downloading necessarily, or other steps that might have been taken to instantiate this object, right? Especially if I use something like a builder pattern, which we're going to talk about. Again, maybe you could come up with all those sort of constructions, but you might want to be able to, again, parameterize some of that and just be able to easily hold on to an object. So it's a nice, very, very simple pattern. And again, when I thought about the clone and I kept looking at the copy constructor, I was like, yeah, it seems like the same thing, but again, the explicitness is nice, the grepability, and there's also other nice things that you can do, because when you initialize an object, you might always be, I mean, this is getting into maybe some of the more interesting use cases that maybe folks will be interested in discussing in the video, where we can have, again, direct control over this initialization of the new object that we're creating. So after this step where we get the initial pointer to something, and I think there could be other use cases of also determining what type of object sort of gets cloned from here, which might be interesting. And maybe that's a little bit of a different use case than the copy, but you could actually have clone functions that return like a, if I actually did have another type here for alien, like super aliens, but I wanted to use the alien as a base with all the attributes and different like stats or data or something. So anyways, those are a few different interesting ideas, hopefully, to think about taking the prototype pattern a little bit further. But again, I think it's a really nice, simple pattern. And again, I think hopefully you understand the motivation. So anyways, folks, with that said, I'm going to go ahead and close this video off. I'm going to point you to courses.mshot.io, where you can find all of these patterns. Let's go ahead and find here that we have covered here in this playlist if you want a distraction-free environment. And if you want to discuss this more, feel free to jump into the forums here at forum.mshaw.io, and we can discuss more, whether you think prototype is useful in C++. Maybe it's more useful in other different types of languages. So I'll be curious to hear your discussions there. Anyways, folks, thanks for your time and attention, and I'll look forward to seeing you in the next one.